If you are new to the channel, then subscribe the channel and press the bell icon for further notification. Okay student, welcome you all to this new lecture in advanced level where we are solving previous year IIT JEE questions on hyperbola. So today we will be solving question number 12, 13, 14, 15, 16 and then 17. Okay, then let's try to solve these questions. Okay. Now if you come to question number 12 to 13, a circle this and the hyperbola this intersect to the point AB. Okay. The equation of the common tangent with positive slopes of the circle as well as to the hyperbola is. So common tangent, you know how to find common tangents. You know the tangents of the hyperbola, this one, and this is not a standard circle. So what you can apply? So you can apply that is changing that xy coordinate, or the distance from it from the center should be equal to 0, 0. So the center is 4, 0, radius is 0. But here I have done from taking one by one options, but there is no need. I have done because I consider this is a common tangent, so the center origin distance from the origin should be equal to the radius I, that which condition is satisfying, again which is satisfying this format. So there is no need. You find the distance from this point, that should be equal to 4. From that you will get directly m. Once you know m, directly you will get the equation. So what is the distance? The distance, if you put 4 comma 0, so it will be 4m minus 0, then plus minus under root 9m square minus 4 divided by under root m square plus 1, that should be equal to 4. So you can solve this one easily. You can solve this one, you will find m. Once you know m, then m will get obviously 2 by 5, 2 by root 5 if you solve it here. So you find this is the equation, that is your option B is the correct option. Here I have done by checking from the option, that also you can do. What is the condition? The distance from the circle should be 4, that is one condition of this tangent, and also this tangent has to bring in this format, because it has to be tangent of hyperbola also. So from here you can do, if you check the options, all 4 options satisfies 1, 2, 3, 4. So first condition doesn't give you the answer. If you apply second one, only A satisfies, I think. B satisfies, that's why B is the answer. If you come to 13, the equation of circle with AB as its diameter, the equation of the circle. Now if you see this hyperbola U, the circle is this x minus center at 4, 0, radius at 4, this one. So center at 4, 0, radius at 4, so obviously it will touch and it will go 8, 0. And your hyperbola, you see it is 3, 0, 2, 0, 0, 2. So it is 3, 0. So it is going through like this. So this is the AB. So they have asked you to find circle with AB as diameter. So obviously its center will lie on the x-axis. If its center is lying on the x-axis, obviously its F component will be 0. That means no y is there. So obviously all 4 options satisfy. It should be, center should be of h, 0 format. So all these 4 equations give h, 0 format. So next what I did, next your h, that your this one should lie between 3 to 4. So you check which option lies between 3 to 4, the option A. So by checking A, you can give the answer, or because you 3 to 8, because your h, you can see the center lies between 3 to 8. So which option gives between 3 to 8, that is A. Or you solve these 2 equations. This is one equation, this is one equation, where they cut each other. Let us find this point. So you can put this one in place of y square, this x square minus 8. So if you solve it, you will find this point. So this is the point 6. So this is the center. So with this center, you check which option is satisfying with this center. You will see that only option 1 is satisfying. You can find this distance also once you know this 6. If you put that x, you will find y, this height, then you center radius you got, then you can find the exact equation of the circle. But no need, you can check with the options anytime after doing step by step. 14. The line is a tangent to the hyperbola this. If this line passes through the point of intersection of the nearest directrix and the x-axis, then the eccentricity of the hyperbola. So what they are saying, that a tangent, this line is a tangent to the hyperbola this line passes through the point of intersection of the nearest directrix and axis. So nearest directrix, suppose this is a tangent, so it passes through the point of intersection of directrix and the x-axis. So point of intersection is this one, and this point is nothing but A by E, 0. So the tangent is passing through this. So you can calculate A by E. So first you calculate what is this point, that is you have to find. So this line is tangent, they are saying. So once you know this line, so if you put x equal to 0, you will find this coordinate. So if you put y equal to 0, you will find this coordinate. So x equal to half. That means A by E is given as half. So 2 is given as half. Okay. And the tangent to hyperbola is this one, you know this one. Okay. So this is the equation they have given. This is tangent, and the original tangent should form this format. So from comparing these two, you can find what is your m. M is equal to minus 2. So you put it there, and this should be equal to 1, the constant. So you put it there, m is equal to -2, you got a equation, and you already know equation involving a and d. Here also you can bring e, if you put b square. So one equation between a and d, another equation between a and d, or you can replace a by e, b by e, a and d, then finally again a by e. So you will find the equation of a. If you solve it, you will find the equation of e square is 1 and 2. So e square cannot be 1 because it is hyperbola, so e should be greater than 1. So this one, e cannot be negative also because it is the ratio of the two length, so it is 2. So that means eccentricity is 2 there, that is the answer. Now if you come to 15, let the point on the hyperbola, if the normal to the point P intersect the x-axis at 90, then the eccentricity of the hyperbola. Okay, what is the equation of the normal? You have to remember it, or you can derive it from the tangent equation. So this is the equation of normal because they have given you one point. So if you put the point x1, you got this equation. Now it has to pass through, they are saying 90, this passes through 90. If you put it 90, you will find the equation between a and b. And also you have a equation between, you need to find eccentricity. So once you know relation between a square by b square or b square by a square, then you can put it in e is equal to under root 1 plus b square by a square, e. So you put it, you got it directly, that answer. 16, the eccentricity of the hyperbola, this is reciprocal to the ellipse if the hyperbola passes through the focus of the same type of question we have already solved in starting, but a little difference is there. So it is easy, you can see the hyperbola be the reciprocal of this. You know this eccentricity, so you inverse it, you will get the eccentricity of this one. And it is passes through the focus of the ellipse. So you can find the focus. You can find the focus of the ellipse. So that focus will be the vertex of this one. That means you can calculate E easily, A easily. So first let us calculate the eccentricity E of that ellipse. Then you inverse this one. You got the focus. So eccentricity of the hyperbola will be inverse of this one, and this is one vertex because it is going to A. A is root 3. So A is root 3, so A square. And B you can calculate, you know A and E, so you can calculate B. So this is the equation of that hyperbola. And also they are asking the eccentricity of the hyperbola. Once you know equation, you can calculate, they are asking the focus. Eccentricity is not this one, so C is not the answer. So out of these two, D is the answer, and you check this one B also because it is multiple correct. You calculate focus also. Once you calculate focus AE, you got B is also correct. That is 2, 0. Now if you come to last one, 17, the tangent are drawn to the hyperbola this, parallel to the straight line this, and point of contact of the tangents of the hyperbola. Okay. So again, this is the equation of tangents. Okay. And this is parallel to this line. So what is the slope of this line? If you make it in standard form, this one, so slope is this one m. So obviously the slope will be this one m. Okay, so once you know slope of this one m, so you know the equation of this line. What will be again, I don't remember this one directly. So if you put m there, so you will get the equation of this format, y equal to 2x plus minus 2 2s are 4, 36 minus 4, 2 2s are 4, 4 9s are 36, 36 minus 4 is 32, 32 is 4 root 2, 16 into 2, 4 root 2. So this is the equation. So this one you can write it x minus y is equal to minus plus or plus minus 4 root. Now what is the format of this one? Tangent at the point x1 y1. Suppose this is on a point on the parabola, on the hyperbola x1 y1. What is the equation of the tangent? X1 by 9 minus y1 by 4 is equal to 1. So I told you compare with these two because these two represent the same line. If you make it same line, then you find the corresponding x1 y1 point. So 2 divided by it is x1 by a 9 is equal to minus 1 divided by y1 by 4 minus is equal to plus minus 4 root 2 divided by 1. So if you take this one, you compare these two, you will get x1, 2 value of x1. 1 will be, you will get it. Now you can see it is 9 into 2 divided by minus 4 root 2 or 9 into 2 divided by plus 4 root 2. Along with that you will find y values also. Once you take plus, you will get one set. Once you take minus, you will get another set. So this is your option A is out of this, is satisfying this one. So otherwise you remember this one, you put it there, then you will also directly get it. If you like the video, then press the like button and please give your valuable comments in the comment section.